Alright, we're going to be looking at some questions on the 3D geometry, things like area, surface area, volume, and the like. So here's question number 1. A shipping container, it's a cuboid, which is a fancy way of saying a rectangular prism. We've been given the dimensions 16 meters, 1 3/4 meters, and 2 2/3 meters. We first have to calculate the exact volume. So we know that volume, if we look this up in the formula package as well, we know that for a cuboid our volume is equal to our length times our width times our height. So on our calculator, let me actually just write down the substitution first, including units. It's always good to show your work like this, show the formula and then show the substitution. And now let's go to the calculator, which I've just already reset. So here we go, 16 times 1 3/4 is 0.75, so 1.75. And then 2 2/3. Okay, that's a little bit more complicated here. So over here I'm just going to convert my 2 2/3 into a mixed fraction. Alright, that's like saying 2 plus 2/3, isn't it? And 2, if I write it with a denominator of 3, it's like I've got 6/3. So if I got 2 whole pizzas and I cut them into thirds, I got 6/3. And so obviously I've got a total of 8/3. And so what I'm multiplying by over here is 8/3. And we get 74.66667. Oh, it says to give our answer as a fraction, doesn't it? So let's press math and convert our answer to a fraction. And we get 224 over 3. Okay, so the volume is 224 over 3. And let's put in the units. Very important I include the units in all of these kinds of questions. Meters cubed for volume, because I did meters times meters times meters. There's meters cubed. Now Jim estimates the dimensions to be 15 by 2 by 3. And so let's figure out what Jim's estimated volume is. So this is the estimated volume, while this one up here is the actual volume, isn't it? So our estimated volume, according to Jim, is 15 by 2 by 3. And 15 by 2 by 3 gives us 90. Alright, so now we need to calculate the percentage error. And percentage error is equal to the difference between the actual and the estimated divided by the actual. So our actual was 224 over 3. And we need to subtract the estimated, which was 90. And we're going to compare this difference to the actual. Alright, let's see what we get then. 224 over 3. And now I'm going to subtract 90. Let's see what I get. Alright, and now I'm going to divide this by... I'm going to put this into brackets to make sure the 224 over 3 is included entirely as the thing I'm dividing by. And I get negative 0.205. Now actually in my percent error I probably should have put an absolute value on the top to ensure I get a positive answer, and I forgot that I needed to multiply by 100% at the end, don't I? So if I multiply this by 100, it will give my answer as a percent. And because I'm taking the absolute value of the top, I'm not interested in whether a percent error is positive or negative. Well then let's just interpret this as a positive result of 20.5%. Question number 2. So Sylvia's making a square-based pyramid, and each triangle has got a base length of 12 centimeters and a height of 10 centimeters. Okay, so that must mean that this distance right here is 10 centimeters, because each of these triangles got a height of 10. And if we've taken our 12 centimeters and obviously we split it into 2, 6 centimeters, 6 centimeters. Okay, so I'm just labeling what I can see. I need to show that the height of the pyramid is 8 centimeters. Okay, well look, I can complete a right triangle here, and this length right here, of course, is halfway across the square-based pyramid, and so that one's going to be then only 6 centimeters. And I've got this right triangle here that's formed by the slant heights, hypotenuse, and then the base and the actual vertical height, which are meeting at right angles. And so if we call this the h, then for part A, I can see that in Pythagoras, h squared plus 6 squared, the sum of the squares of the legs, is equal to 10 squared, which is the square of the hypotenuse. 8 squared will equal 100 minus 36, which is 64, and thus h is equal to 8 centimeters, as required. Now, you'll notice that this was a show that question, and we know that in show that questions, you should not include the 8 centimeter value that you've been given. We've got to come up with this only at the end of a legitimate process. They gave us the answer for free just in case we weren't able to come up with the 8 centimeters, but then we would still be able to do the rest of the question. Like, for example, in part B, we need to calculate the volume of the pyramid. Volume is equal to 1/3 times the area of the base, which in this case is a square, whose length is 12 and its width is 12, so that's 12 squared is the area of the base. And then we need to multiply it by the height, which we've already discovered now is 8. So let's put this in the calculator then. We've got 1/3 times 12 squared times 8. 384. And let's think about the units again. 384, because it's a volume, it is centimeters cubed. Part C, Daniel wants to make a rectangular prism with the same volume as that of Sylvia's pyramid. Okay, so Daniel's volume is also going to be 384 centimeters cubed. Alright, so this is Daniel's volume. On the next step, we know we can replace it with a 384. The base of his prism is to be a square of side 10 centimeters. Alright, so you imagine Danny's prism here. It's a square-based prism. And so this square base is 10 centimeters by 10 centimeters. And we don't know what the height of his prism is. That's what we have to find. So we can see that his volume is found by 10 squared, which is the area of the base, times the height, which is h. We don't know what h is yet. So 384 is equal to 100h. And now you can see we can divide both sides by 100 to discover that h is equal to 3.84. And don't forget the units, centimeters. You'll find that in all IB exams, there is 1 point allocated for the use of units. The first time that you forget units in a unit question, you probably will be deducted that point. Now, I know that IB has recently had some changes in which they've said that they're only going to deduct in one specific pre-selected question, but you don't know what question that's going to be. So if I were you, I would include units on every single applicable question in order to preserve that mark. Number 3, tennis balls are sold in cylinder tubes that each contain 4 balls. We got the radius of the tennis ball, we got the radius of the tube, and the length of the tube is 26 centimeters. I'm just going to draw a quick diagram of the situation. It helps me think through things. So I can fit in 4 balls, 4 balls in my cylinder. And the radius of each tennis ball, so that's halfway across the tennis ball, 3.15. The radius of the tube itself is 3.2. Yeah, I guess it would have to be a little bit bigger, wouldn't it, in order for the tennis balls to fit. And then our height is 26 centimeters. Fine. We need to find the volume of one tennis ball. Well, the volume of a tennis ball, it's the volume of a sphere, where volume is equal to 4/3 pi r cubed. Always a good idea to write down the formula first. And now let's substitute into that formula. We know that the radius of the tennis ball is 3.15 centimeters. Let's put this in the calculator then. 4/3 times pi, which I can find second exponent, and then I need to multiply this by 3.15 to the power of 3. And we've got 130.92. If I'm going to round this to 3 significant figures, then I guess I get approximately 131, but we know that IB no longer penalizes for including additional significant figures, and so we could leave it like this, but I'm going to write it like this, just because I like 3 sig fig. Part B, calculate the volume of the empty space in the tube when the 4 tennis balls have been placed in it. Alright, so I guess we're going to have to find the volume of the entire tube, and then we'll have to subtract the space that's being taken up by these tennis balls in order to find all of the space that's left in between them. So let's find the volume of the cylinder first. Okay, so the volume of the air that we're looking for is going to be the volume of the cylinder minus 4 times the volume of the sphere. Alright, the volume of the cylinder can be found by doing pi r squared h, and in this case our r is 3.2 because we're now looking at the tube's radius in order to calculate the cylinder. Pi r squared h, and our height was 26. And then from this I need to subtract 4 of the spheres. Now, rather than using this 131, this rounded value, I'm going to use the exact value that I had up here before I started approximating and rounding decimals. And so I'm just going to write down this expression again in order to preserve accuracy. So let's put this in and see what we get. So we've got pi times 3.2 squared times 26, and then from this I need to subtract 4 times 4/3 times pi times 3.15 squared, or cubed, sorry. And I know that some of you might be looking at this and you're a little worried about order of operations, but look, these are all multiplieds and divides. So these are all going to happen together as a group before we subtract that quantity. So amazingly, I actually don't need any parentheses in this expression, and I end up getting an answer of 312.72, but as you can probably guess, I like to round this to 3 significant figures. And don't forget, we're talking about a volume, so it's centimeters cubed. Now, I'm just thinking about this for a moment. This worries me just a little bit. I wouldn't have expected to have quite as much empty space in the tube as that. Does that seem reasonable? Gosh. And let's see, 1 tennis ball is 131, so we're dealing with like almost 3 tennis balls worth of space. Well, maybe that is almost reasonable. I guess you could argue that you could fit in like a big part of a ball there, and another one, and another one, and another one, and another. Wow, 3 balls worth. I don't know. Well, anyway, I don't see a problem in what I entered, so I'm going to leave this, and obviously you can compare your solutions to the mark scheme. Hopefully I didn't miss this one. Question number 4. The base of a prism is a regular hexagon. The center is O. The length of OA is 15. We need to write down the size of angle AOB. Well, I know there's 360 degrees in a full circle, and I've divided it into 1, 2, 3, 4, 5, 6 equal pieces. 360 divided by 6 obviously gives me 60 degrees. So that's part A. Part B, find the area of the triangle AOB. Well, one way I could do this then is AOB. I guess I could create a right triangle height on it. One property of a regular hexagon is that it is composed of 6 identical equilateral triangles, as you can see, of course, if their angles are 60 degrees. And obviously this is 15 and this is 15, so these 2 angles must be the same, so the remaining 120 degrees in the triangle has got to be split 60-60. So these are equilateral triangles, which must mean that our outer lengths are also 15 centimeters. So we've split it then into 7.5 centimeters and 7.5 centimeters, which allows us to use the Pythagorean theorem on this triangle right here in order to find the height. So let's call the height h. So we'll use Pythagorean theorem, h squared plus 7.5 squared equals 15 squared. So h squared will equal 15 squared minus 7.5 squared. That one I don't know. 7.5 to the power of 2 is 56.25. And so if I do 225 minus this answer, I get 168.75. Let's take the square root of that result. Square root of my previous answer. And I end up getting 12.99, which indeed, of course, we can round to 13.00. But you know what? Let's leave it with extra figures of precision, because this isn't actually the final answer yet. I need to find the area of the triangle now, and I know the area can be found by 1/2 times base times height. In our case, the base of the triangle is 15 centimeters, and the height of the triangle I've just discovered is 12.99 centimeters. So 1/2 times 15 times 12.99, 97.49, which I can round to 97.5, and because it's an area, it's centimeters squared. And part C, find the volume of the prism. Well, any prism's volume is equal to the area of its cross-section base times its height. We've just discovered that one of these triangles is equal to 97.5 approximately. Let's multiply that by 6 to get the entire hexagons, because of course there's 6 equilateral triangles in it. So 584.95, 955, and it says that it's 20 centimeters tall, so let's multiply this result by 20, and I'll round my answer, of course, to 3 significant figures, 11,700. And it's a volume, so now it's centimeters cubed. And we'll continue with numbers 5, 6, and 7 in the next part of the video.